Hi, I'm Radek, I'm a developer advocate at QuickNode, and in this video I will walk you through what is a smart contract, how does a smart contract work, how to write and deploy an Ethereum smart contract, and how to interact with a smart contract. Ready? Let's go! So let's dive into one of the most exciting aspects of blockchain technology, which is smart contracts. A smart contract is essentially a self-executing contract where the terms of the agreement are written directly into the lines of code and put on blockchain. You can think of a smart contract as a vending machine. With a traditional contract, you'd give your money to someone, to a lawyer or a notary, whoever else, and they would handle all the paperwork and do everything else. But with a smart contract, you simply drop a token into that vending machine and your escrow, your driver's license, or whatever else drops into your account. What's important is that smart contracts also define and automatically enforce all the rules and penalties of an agreement, which is not the case for standard contracts. Another super important feature of smart contracts is that they eliminate the need for trust. You don't need to trust the other party to do what they said that they would do. If something is written into a smart contract and the agreed conditions are met, it automatically gets executed. You don't need to trust anyone. Ethereum is crucial for smart contracts as it was built specifically to facilitate their creation and execution. And one of the key aspects of Ethereum is its Turing completeness. In computer science, a system or a language is said to be Turing complete if it can solve any computational problem given enough resources. This makes Ethereum a very flexible platform for creating complex smart contracts that can do practically anything. At the core of Ethereum is EVM, Ethereum Virtual Machine. It executes smart contracts on the Ethereum network and acts like a part of the whole Ethereum blockchain. Okay, so how to actually write and deploy a smart contract on Ethereum? Smart contracts on Ethereum are overwhelmingly written in Solidity and often deployed and tested using Ethereum Remix IDE, which is an open source browser-based IDE for Ethereum smart contracts, and this is what we will be using today to do it. We'll deploy a smart contract and put it on Sepolia test network, but before we do that, we will need to get some test ETH so that we can pay for gas to actually deploy the smart contract. For that, you need to go to faucetquicknode.com, connect your wallet, connect MetaMask, and choose Ethereum and Sepolia. It already has my wallet address automatically. Continue. I can either get 0.05 ETH or I can double that if I tweet the URL. Let's just get 0.05 and transaction is now in queue, and soon it will add 0.05 ETH into my wallet on Sepolia test network. Transaction completed, so I have now added 0.05, which is visible here. Now that I have play money, let's play and let's write and deploy that smart contract. To create a new smart contract file, go to File Explorer here, Contracts, create new file, test contract.sol, and this is where we write our code. I have a sample code ready here, so let's have a look what it does. The first line is the type of license used for contracts. The second is the version of Solidity. The latest one is 0.8.20. And now we are starting our contract, which is contract, the name of the contract, and we open curly braces. Now we do a few things here. We initiate a private variable named count and set it to 0. We then create a function named increment, which is then public, means that anybody can call this function to that smart contract. Private means that only the creator of the smart contract can access that variable or that function. So this one is public, anybody can increment that, and what it does is that it takes the private variable count and adds 1 to it. And in order to also show what the actual count is, we need to create a public function which gets the count, because this one is private, so it's not possible to see from outside. So what we are just doing in the public function is that it returns that private variable and shows the current number of the count. And that's about it. Now we need to compile it into bytecode, because that's what is getting put onto the blockchain. Not this code, but bytecode goes onto Ethereum blockchain. To compile, let's go to this Solidity icon, and compilation failed for a simple reason. We have chosen the latest Solidity, but here the compiler is 0.818, not 20. So we just need to select one that is compatible with what we are using and then try to compile again. Now everything compiles properly. We are ready for deployment. To start the deployment process, go to the next deployment section, which is this Ethereum icon. And if you want to put it on testnet, on Sepolia, for example, you need to change from virtual machine, which is just everything on your computer, to injected provider MetaMask. And because I have Sepolia already selected here, as a test network, it shows that I will be using MetaMask to fund it, and it is showing the correct network, which is Sepolia, which is what we want. Make sure that the correct contract is selected, test contract, and click deploy. Now it asks to confirm the transaction and to pay the fee to put the contract on blockchain. So we are paying gas and we are deploying our contract on Ethereum testnet on Sepolia. Confirm, and transaction recorded. So now it's waiting for transaction confirmation. Boom, now it's ready. Now we have deployed our contract, and this is where we can see that deployed contracts. This is the contract here. We have the contract number. Interesting thing about this number. So every smart contract has a different address, same as like wallet address. This is smart contract address. And the way it's being derived is that it takes my wallet address, which is this, like 2597, and it also takes my nonce, which is the number of transactions that I have as this account. And with those two variables, the wallet address and the number of transactions that this wallet generated, it takes and does some magic. It first encodes it and then hashes it so that an outcome is a hash, which is the address of the smart contract. And it's always unique because there's always a unique combination of wallet address and the number of transactions that the wallet address has done. But that's just what happens behind the scenes. Now let's have a look at what we have deployed. So we have deployed our contract and we can check what's the current count. It should give us 0 because this is set to 0 and we haven't done anything with it yet. We haven't incremented it. So let's check the get count, and to get the count, and this returns 0 here, which is what is being expected. To get the count, we don't need to pay any gas fee. To read from blockchain, we don't pay gas fees. We only pay gas fees to write to blockchain, like for example, write a transaction or deploy a smart contract. So let's try and increment now. What incrementation does is that we increment the number and then we keep that number on the blockchain. It means that we are writing to blockchain, so we will need to pay a gas fee and to create a transaction. So this is what should happen. And automatically we have a MetaMask window asking for us to confirm and sign the transaction with an associated gas fee. We are confirming that. And as soon as it goes through, we should have a get count or a count variable 0 plus 1. And let's have a look. Okay, it went through. So let's get a count again. And a count is 1 now. So congratulations. In a couple of minutes, we have learned what smart contracts are and how they work. Then we have written a smart contract, a simple one, deployed it to an actionable blockchain, then interacted with the smart contract by reading from it and then even writing to it. And that's a lot. Congratulations again. Now keep learning, check more of our videos, ask questions you can write in the comments, and see you soon.